In this video, we're going to learn about geometric sequences, and we're going to talk about the explicit versus the recursive formula. So by this point, you've probably already watched or learned about an arithmetic sequence. So we're going to talk about how a geometric sequence is different. So as you learned already, an arithmetic sequence is a pattern or a list of numbers that has the pattern of where you add the same number every time to get the next number. A geometric sequence is where you have a list of numbers that have a pattern and you are going to multiply by the same number to get the next number in the pattern or in your list. And just note that this number that you're multiplying by, which is called the common ratio, is the number that you multiply by, and we call it R. It can be an integer, which is a whole number that's positive or negative, or it can be a fraction. And so I have just an example of each one just to kind of show you how this works. So remember, a couple things we need to remember are term numbers. Term number just talks about the list, like in your list of numbers, what number you're talking about. So in my first pattern here, this is my first term, my second term, my third term, my fourth term, and my fifth term. We just say that really just means it's like the fifth number in your row of numbers or in your list of numbers. That's what it means to be a term. Okay, so let's look at this integer part first. So I'm trying to determine, how do I get from 4 to 8? Well, I multiply by 2. How do I get from 8 to 16? I multiply by 2. How do I get from 16 to 32? I multiply by 2. And how do I get from 32 to 64? I multiply by 2. Maybe you can't see that right away. So what you can do to find the common ratio, R, is you take your second term and divide it by your first term. So in this case, I would do 8. Oops, sorry, my pen's being silly. 8 divided by 4 is 2. Then you want to make sure that that works the whole time. So if I'm here, that means that my common ratio is 2. So is 4 times 2 8? Yes. Is 8 times 2 16? Yes. Is 16 times 2 32? Yes. Is 32 times 2 64? Yes. So in that pattern, every time you're multiplying by 2, you should be getting the next number. If that's not the case, if you multiply by 2 and you don't get a number that you should, then it's not a geometric sequence. So let's look at if we're multiplying by a fraction. So I happen to notice that to get from 100 to 50, well, that's half. 100 times 1/2 is equal to 50. And to get from 50 to 25 is 50 times 1/2, 25, or half of 50. Sure. What's half of 25? 12.5. And again, to find your common ratio, we are going to take our second term, which is 50, divided by our first term, which is 100. And if you reduce that as a fraction, it gives you 1/2. Okay? So we can either be multiplying by an integer, a whole number, that's either positive or negative. And when we do that, our numbers are going to be increasing. They're going to keep getting bigger. When I multiply by a fraction, a number that's smaller than 1, you'll notice just as in this example, going down my line, my numbers are getting smaller. Okay, so just like in an arithmetic sequence, a geometric sequence, we have two formulas. We have what's called the explicit formula, and we have the recursive formula. We'll talk about the explicit formula first. Okay, so in the explicit formula, this a sub n is talking about the nth term. So when we talked about term number, if I wanted to write something like a sub 2, that is I'm talking about my second term. And if I go back up to my list up here, my second term right here is 8. Okay, so just so you understand how to read that part. Okay. A sub 1 is my first term. Okay, that's going to be the term that comes first in my list. R is our common ratio. That's the number that we're multiplying by every time. In this case up here it was 2. And N, that represents our term number. So if we go back to this A sub 2, that means that my N value is 2. And again, we're talking about the second term. So just kind of how you read this information. So just for example, to see how this works, if we wanted to use this explicit formula, we know for this example here on the left where it's 4, 8, 16, 32, 64, we know that our first term is 4 because it's the number that comes first in my list. And we know that we figured out our common ratio, or our R value of 2. So let's just say we have the first 5 terms. What if we wanted to find the 7th term? So I would say, okay, A sub 7 is equal to my first term, which is 4, times my common ratio is 2 to the 7 minus 1. Okay? So I have to do 7 minus 1 first. I'm going to evaluate this first. So this becomes 4 times 2, whoops, to the 6th power. And then you can type in the whole thing on your calculator if you wish. So you can go ahead and you can open up your Desmos. So you could type in 4 times 2 to the 6th, and we get 256. Or you could do 2 to the 6th first if you're doing order of operations, then you multiply it by 4. So this becomes 256. So that would be my 7th term. Okay, now does that make sense? If I multiplied by 2 to get my 6th term, 64 times 2 gives me 128. And then I keep multiplying by 2 times 128 times 2 equals 256. So that makes sense. Okay. All right, let's go over here and talk about the recursive formula. So the recursive formula, I'm looking right here, okay? We have to have 2 pieces of information. We have to have my first term, and we'll use this list up here, this 100, 50, 25, 12 and a half. So in this case, my first term is equal to 100. And we also need to know our common ratio, which we found was half. And then we do here is we use previous terms to find the next term. So how this works is, let's just say we have the first, let's see, if this is my first, this is my second, this is my third, and this is my 4th term. If I want to find the 5th term, okay, so I'm going to use term number 5. So my 5th term is equal to my common ratio, which is a half, times a to the 5 minus 1. We do this part first. Ooh, you can't see that. So this becomes 1/2 times the 4th term. So I come back up here and I see that my 4th term is 12 and a half. So this is what's 1/2 of 12 and a half. So half of 12 and a half, and feel free to use a calculator if you can't do this in your head, gives you 6.25. That would be your 5th term. Comes next in the list. So does it make sense if 1/2 times 12 and a half is 6.25? Okay, so that's how these work. Why do I have 2 different formulas? Okay. I want to use the explicit formula over here when I'm trying to find a large number of terms, or if I'm trying to find a large term number. So say you were asked to find the 100th term or the 250th term. You don't want to do the recursive method where you have to find all the previous terms. You just want to be able to plug in a couple numbers and get the answer. Where this recursive formula is really beneficial when you just want to find like multiple terms in a row. Or if you're finding a low term number, you can easily see here, well, if we come back up here, well, the pattern is just multiply by 1/2. So times 1/2 is 50, times 1/2 is 25, times 1/2, 12.5, times 1/2, 6 1/4. So when you're finding low numbers and the pattern's really easy, especially if you can do it in your head, recursive is the best way to go. So I have a couple examples for you that kind of address all of these two types of problems, and they get a little bit progressively harder. And just as a reminder, when you're finding your common ratio, your R value, take the second term and divide it by the first term. And then you always want to check just to make sure that you're actually dealing with the geometric sequence, because sometimes they like to give you ones that aren't, just to make sure you know what you're doing. Okay, so here's some examples. First one says, write a rule using the explicit formula and find the 52nd term. Okay, so the explicit formula says a sub n is equal to a sub 1 times r to the n minus 1. All right, so I have to figure out what's my first term, and I have to find my common ratio. So my first term, that's easy. That's the first number that comes in the list. That's 6. To find my common ratio, I take my second term, a sub 2, and divide it by my first term, which is a sub 1. This is my second term, and this is my first term. So I'm going to take 18 and divide it by 6. Gives me 3. Okay, perfect. And then, so I'm going to write my rule. So my rule says a sub n is equal to my first term, 6, times my common ratio to the n minus 1. This is my formula. We don't plug in any numbers besides a sub 1 and r. Now I'm going to find the 52nd term. Now I'm going to use this n. I want to be 52, so I plug this in. A sub 52 equals 6 times 3 to the 52 minus 1. I first do this part, 52 minus 1. So I get 6 times 3 to the 51st power. Okay, so and I'm going to plug that in on my calculator. Over here I have 6 times 3, try that again, 6 parentheses 3 to the 51st power. I get a really huge number, 1.2922 times 10 to the 25. So that's written in scientific notation. That's okay that it's written in scientific notation. I forgot what it was. 1.29 times 10 to the 25. So a sub 52 is 1.29 times 10 to the 25. In scientific notation, that means that after this decimal point, there are 25 more place values. So 1, 2, 3, 4, 5. You keep going until you get to 25. So there's lots of zeros added on there. So this is the best way to write it out. It's a pretty big number. And these numbers grow really fast because we're multiplying by the same number every time, not just adding. So the growth, it gets really big, really fast. Okay, next. This one says, find the first 4 terms of the sequence given by a sub n equals 550 times 1/5 to the n minus 1. Okay, so when you're given a formula, you kind of want to work backwards. You should be able to recognize how much is your first term and what's your common ratio. My first term is always the number that's given first right here. So my first term is 550. And my common ratio is the thing that we're raising to the exponent, and that is 1/5. So they want me to find the first 4 terms. So a sub 1, we already know is 550, but I would kind of want to show you in this formula why it works out. 1 minus 1. And maybe this will help clue you in as to why you subtract 1 also, because that's always a question. gives you 550 to the 1/5 to the 0 power. Anything to the 0 power is 1. So this becomes 550 times 1, which is 550. Okay. I'm going to shrink this so that we have some space. A sub 2 is 550 times 1/5 to the 2 minus 1, which is 550 to the 1/5 to the first power. And again, use your calculator. 550, we'll just keep it open here. 550 times 1/5, and I want to raise it to the first power. Gives me 110. Okay, let's do the next one. A sub 3. 550 times 1/5 to the 3 minus 1, or 550 times 1/5 to the second power. 550 times 1/5 to the second power gives me 22. Look how fast it's going down. We started at 550, and on the third term, we're already at 22. Okay, and last but not least, we'll kind of do it over here. We'll do a to the fourth power is equal to 550 times 1/5 to the 4 minus 1, or 550 times 1/5 to the third power. Is 4.4. Okay. So if we zoom all this out, we'll write all our terms so we can kind of get an idea of where we are. So our first term was 550. Our second term is this blue guy, 110. Our third term jumps down to 22, and our fourth term is 4.4. See how fast it drops? Because we're multiplying again. So even when we're multiplying by a fraction, the numbers get really small really fast. And when we multiply by a whole number, our numbers get really big really fast. Okay. Last example. This one's a little bit tricky. So this one wants to write the recursive rule for the sequence below and find the next 3 terms. Okay, so the recursive rule says this. You need to list your first term. And then you take whatever your R value is and you multiply it by the previous term. So, and minus 1. So we have to fill in this value here and this value here. Okay, the first term is easy because that's the number that comes first. So we can say that a sub 1 is equal to negative 2. Okay, and we need to find our R value. So remember, to find our R value, we take our second term and we divide it by our first term. Okay, so 4 divided by negative 2 is negative 2. Let's check to make sure this works. Negative 2 times negative 2 is positive 4. Positive 4 times negative 2 was negative 8. Negative 8 times negative 2 is positive 16. And positive 16 times negative 2 is negative 32. So that's something to notice. When you have a list of numbers or your sequence that alternates signs, that should be a clue that you're multiplying by some type of negative number because it's flipping positive, negative, positive, negative. Okay, so, and our common ratio is also negative 2. Okay, so when I write my formula, I can say that a sub 1 is negative 2 and a sub n is negative 2 times a to the n minus 1. All right, find the next 3 terms. So I have the first, second, third, fourth, fifth. I need to find 6, 7, and 8. So to find the 6th term, a sub 6 is equal to negative 2 times a to the 6th minus 1, or negative 2 times a to the 5. And my 5 term is negative 32. So negative 2 times negative 32, and if you don't know, you can use the calculator, gives you positive 64. Okay, makes sense because I went from a negative to a positive. Let's find my 7th term. My 7th term is negative 2 times a to the 7 minus 1, or negative 2 times a to the 6. And my 6th term is what we just found right here. So it gives me negative 2 times 64. And if you don't know off the top of your head, you can use a calculator. Gives you negative 128. And this is my 7th term. Okay, and then I want to find my 8th term. A sub 8 is negative 2 times a sub 8 minus 1, or negative 2 times a sub 7. And a sub 7 is this term, negative 128, which we just found. Negative 2 times negative 128 is equal to positive 256. Okay, so when you're working with geometric sequences, remember you're multiplying by the same number every single time. And you can either use the explicit or the recursive formula, and you get to choose if they don't tell you. But remember, you want to use this explicit formula when you're trying to find a large number term. Otherwise, you just have to keep taking the previous term and multiplying it by that same number. And if you don't want to have to do that 100 times, that will take a long time. So if you have any questions, let me know. Otherwise, good luck.